Welcome back to Crushing Design Patterns in .NET. In our last episode, we mastered the strategy pattern to make our algorithms interchangeable. Today, we are tackling a new challenge. How do you let multiple objects react to a state change in another object without creating a tangled mess of dependencies? The answer is one of the most important patterns for building event-driven systems, the observer pattern. Let's see how our expert Arohi uses this pattern to design a clean and decoupled notification system. Arohi, welcome. Today's scenario is for a stock market monitoring application. We have a StockTicker class that gets real-time price updates for a stock, like MSFT. We need multiple parts of our application to react to these price changes. For example, a price dashboard needs to update its display, and an alerting service needs to check if the new price triggers any user-defined alerts. How would you design this so the stock ticker doesn't need to know anything about the dashboard or the alerting service? What is the naive, problematic approach to solving this, and why is it a bad design?
The naive approach would be to tightly couple the stock ticker to the objects that need to know about its changes. Inside the stock ticker's update price method, you might see direct calls to the other classes. This is a terrible design. The stock ticker is now directly responsible for managing all its dependents. If we want to add a new component, like a portfolio manager, we have to go back and modify the stock ticker class. This violates the open/closed principle and creates a rigid, tangled system.
How does the observer pattern solve this problem of tight coupling?
The observer pattern provides a brilliant solution. It defines a one-to-many dependency between objects. When one object, the subject, changes its state, all of its dependents, the observers, are notified and updated automatically. The key is that the subject knows nothing about the concrete observers. It only knows that they are observers.
What are the first steps to implementing this? How do you define the subject and observer roles?
We start by defining two interfaces, which is the standard C# approach. One for the subject, which I'll call iStockTicker, and one for the observer, iStockObserver. The iStockObserver interface defines the update method that the subject will call. The iStockTicker interface defines the methods for managing subscribers, register, unregister, and for triggering the notification, notify observers.
How would you implement the concrete stock ticker, the subject?
The concrete stock ticker class will implement iStockTicker. Its main job is to maintain a private list of its observers. As you can see, when update price is called, it finishes by calling notify observers, which simply loops through its list and calls the update method on each registered observer. It has no idea what those observers are or what they do.
Now, let's create the concrete observers. How would the price dashboard and alerting service look?
They become very simple. Each one just needs to implement the iStockObserver interface. Each observer contains its own specific logic inside the update method. They are completely independent of each other and of the stock ticker.
How does the client code wire all of this together?
The client code is responsible for creating the subject and the observers and then subscribing the observers to the subject. Now, if we want to add a portfolio manager, we just create the new class and register it. The stock ticker never changes.
This looks a lot like C# events. What's the relationship between the observer pattern and event?
That's a very sharp observation. C# events are in fact a first-class, language-level implementation of the observer pattern. The event keyword provides a clean and safe syntax for managing the subscriber list and notifications. In a real-world C# application, you would almost always use events to implement this pattern.
Could you refactor the stock ticker to use a C# event instead of manual implementation?
Absolutely. It makes the code much cleaner and safer. The client code then subscribes using the plus equals operator, which is much more idiomatic in C#. MSFT ticker.price changed plus equals dashboard.update semicolon.
What is the key difference between the observer and pub/sub, publisher/subscriber patterns?
They are very similar, but there's a key architectural difference. In the classic observer pattern, the subject maintains its own list of observers and communicates with them directly. In a pub/sub pattern, there is a third component, a message broker or event bus that sits between the publisher and the subscribers. The publisher sends a message to the broker, and the subscribers subscribe to the broker, not the publisher. This creates an even greater level of decoupling, which is essential in large distributed systems.
When is the observer pattern the right choice for an interview problem?
The observer pattern is the answer whenever you hear the requirement. When this one thing changes, multiple other unrelated things need to be notified and react. It's the classic solution for decoupling the thing that changes from the things that react to the change, ensuring your design is flexible, scalable, and adheres to solid principles.
Arohi, you've done it again. You've shown us how to use the observer pattern and C-sharp events to build a clean, event-driven system that is incredibly decoupled and easy to extend. If you now feel ready to implement event-driven notifications in your own projects, give this video a like and comment below if you prefer the classic implementation or the C-sharp event keyword. And of course, subscribe to the .NET Way so you don't miss what's next. In episode 4 of our Crushing Design Pattern series, we are going to simplify complex systems. We'll explore how to provide a clean, simple interface to a large body of code with the facade pattern. Thanks for watching. We'll see you in the next episode.